Hello, everyone, and welcome to Echelon Catapult Space Training course. This course is for the CCIC, which is the California Cyber Innovation Challenge. In this video series, we will be talking about so many incredible things in space, like satellites and space systems, and how to secure and protect them. So we're going to do some introductions. My name is Lauren Jones.
My name is Charles Sander.
And I'm McKenna Gatlin.
Okay, let's get into it.
So we're learning about space systems and satellites in this video course, but you may be wondering, what is a satellite? A satellite is an object that moves around a larger object in orbit, like a planet. An orbit is a path an object takes that circles a larger object. This is often a result of the larger object's gravity. We'll get more into that later.
I have a surprise. We all live on a satellite. What's it called, you ask? The Earth. The Earth orbits around the sun in a circle, so it is a satellite. It's also what we call a natural satellite because it was not intentionally put into the orbit by humans. Earth's moons and all of Jupiter's 79 moons are also natural satellites. But usually when someone says satellite, they are talking about a man-made or artificial satellite. Man-made satellites are machines made by people. These machines are launched into space and orbit Earth or another planet in space. For example, there are currently satellites orbiting the Moon, the Sun, and several other planets, including Mercury, Venus, Mars, and Saturn.
In October 1957, the Soviet Union launched the first Earth satellite, Sputnik 1. This is an example of an artificial satellite. This satellite proved the Soviet Union's technological influence and encouraged the United States into stepping up its game in space.
Satellites are kept in orbit around Earth by a force called gravity. Gravity is the force that pulls all things with mass or weight towards one another. That means that you and I are being pulled toward each other right now. We just don't notice it because neither of us weighs very much, so the attraction is very small. However, Earth has an estimated weight of 6 septillion kilograms, which is also why we feel its gravitational force to a much higher degree. The gravity of Earth is what keeps satellites in orbit. Sooner or later, though, the force of gravity will pull all objects, including artificial satellites, back to Earth. When satellites quit working, they become orbiting space junk until gravity pulls them closer to Earth and they burn up in the atmosphere. Now we will talk about the differences between mass and weight. Mass is an object's weight on Earth. However, if that object goes to another planet, it may have a much different weight because the mass and gravity of the other planet may be less than it is on Earth. For example, I weigh 77.1 kilograms on Earth. I weigh 12.8 kilograms on the Moon. I weigh 194.9 kilograms on Jupiter, and I weigh 5.1 kilograms on Pluto. However, my mass will always be my weight on Earth, which is 77.1 kilograms.
And we will put the link that we use to determine this information in the YouTube description. So yeah. But what do satellites do? Artificial satellites are used to study the Earth, other planets, help us communicate, and even observe the distant universe. We are going to go into a few types of artificial satellites and their applications. A weather satellite is a type of satellite that is used to monitor the weather and climate of the Earth. Clouds, city lights, fires, the effects of pollution, boundaries of ocean currents, energy flows, these are all types of environmental information that are collected from weather satellites. A communication satellite is an artificial satellite that relays and amplifies radio signals. Satellites communicate by using radio waves to send signals to antennas on the Earth. After receiving the signal, these antennas then capture those signals and then process the information from them. The purpose of communication satellites is to relay these signals around Earth, allowing communication between widely separated geological points. Before satellites, transmissions were very difficult or practically impossible at long distances. The signals, which travel in straight lines, could not bend around the round Earth to reach a destination far away. But because satellites are in orbit, the signals can be sent instantaneously into space and then redirected to another satellite or directly to their destination. Communication satellites allow radio, television, and telephone transmissions to be sent live anywhere in the world.
Global Positioning System, or GPS, is a system of satellites that is responsible for determining where certain objects are on Earth's surface. You use GPS whenever you use a Google Maps or when you look up directions to get from one place to another. Triangulation is the reason why GPS works. Triangulation is 3 GPS satellites working together to determine the point of an object. In this picture, look at the red circle. Satellite 1 knows the point it's looking for is somewhere along the line of the red circle, but there are too many points on the circle to accurately figure out what we are looking for. Now we add a satellite 2 with the yellow circle. Our options have narrowed down to 2 possible points, the point where the red and the yellow circles meet. This is a lot better, but we have to get to only 1 point. If we add a satellite 3 with the green circle, we have 1 point. That is how a triangulation works. 3 satellites working together to pinpoint something's location.
So thank you for watching our first video in the CCIC space training series, where we went over like an overview of satellites. If you have any questions, comment them down below in chat or send us an email at team@echeloncatapult.org. On the very next episode, we will be talking about the Deep Space Network, so be sure to click on this video next. Bye!